Hi, good day, and welcome to the Division of Education, Innovation and Energy e-learning program. I'm one of your facilitators, Joseph Frederick, in the area of mathematics. And for this video, we shall continue our exploration of algebra by focusing on binary operations. Our objectives for this video are to explain the term binary operation. At the end of this video, you should be able to explain what binary operations are. You should then also be able to use binary operations to solve problems in mathematics and in algebra. Questions focusing on binary operation are usually found in question number 2 of a paper 2 section 1. Also, we want to do an exploration. We want you at the end of this video to describe the distributive property and solve problems utilizing the distributive property of multiplication over addition and subtraction. So at the end of this video, our hope is that you will be a master in binary operations and distributive property by achieving these objectives. We have looked at binary operations. Now what we want to do is that we want to look at the distributive property. The distributive property, basically it's a law, or we say a property in mathematics. It says that multiplication is distributive over addition and subtraction. And to utilize it, here we have a case where a as a variable is being multiplied by the expression x plus y. In mathematics, we usually write it like this: a bracket x plus y. That means a multiplied by x plus y. Here we have s squared multiplied by m minus n. We usually don't write the multiplication system symbol in algebra. So this a has to be multiplied. This a has to be multiplied by all of x and y. This s squared has to be multiplied by all of m minus m. So before we explore the usage of the distributive law, distributive property, let's just look at some types of polynomials. Polynomials can be classified based on the number of terms that they have. So we can have a monomial. A monomial is a polynomial with only one term in the expression. Here are some examples of monomials. We can have binomials. Binomials are expressions that are made up of only two terms. Here are some examples of binomials in green. They have only two terms. One term, two terms. Here, monomials have only one term. One term. One term. These here have two terms. One term, two terms. One term, two terms. One term, two terms. Monomials, one term, binomials, two terms, trinomial. A trinomial are expressions that are made up of only three terms. Here are some examples of trinomials in black. So now that we know what monomials are, what binomials are, and what trinomials are, let's look at utilizing the distributive property to solve problems involving the product of a monomial and a binomial. So a typical question is going to state, remove the brackets and simplify the following expression. Here is my expression. 7 bracket x plus y. 7 bracket x plus y here means that the 7 is being multiplied by this bracket x plus y. How do we do that? Here we take the 7 and we multiply it by the x. We take the 7 and we multiply it by the y. And what does that give us? 7 multiplied by x is going to be 7x, and 7 multiplied by y, 7y. Let's look at another example. What if we had 2x squared multiplied by 5x minus 3y? Again, whatever is outside of the brackets, utilizing the distributive property, is being multiplied by everything that's on the inside of the brackets. Recall that in the first example, we said that it was 7 times x and then 7 times y. 7 times x is simply written as 7x. 7 times y is written as 7y. So here, now we want to do, it's 2x squared, and the 2x squared has to be multiplied by this bracket. This 2 has to be distributed to everything inside of that bracket. So the 2x squared has to be multiplied by the 5x, and the 2x squared has to be multiplied by the negative 3y. What is that going to give us? Recall here for me. Recall when we were doing in the previous video, when we were doing multiplication of terms in algebra, what we said. We said that when we are multiplying our terms, it is 2x squared, and we want to multiply that now, multiply that by 5x. Multiplying all terms in algebra, what we can do, let's use another symbol to represent multiplication, shall we? Using another symbol to represent multiplication, we can utilize the x that you know. Remember we said that to write your x's in algebra slightly different to how you would write multiplication. So it is 2x squared multiplied by 5x. Remember, we said that multiplication is commutative. Commutative says that we can rearrange them. The answer would still be the same. And that 2x squared is 2 multiplied by x squared. And 5x is 5 multiplied by x. So this here is going to be 2 multiplied by x squared. 2 multiplied by x squared. So it's 2 multiplied by x squared multiplied by 5 multiplied by x. You see that my x's and my multiplication signs are different. So we can rearrange this here. This becomes 2 multiplied by 5 multiplied by x squared multiplied by x. Once we are multiplying, we multiply our numbers. It's 2 times 5 is going to give me 10. And x squared multiplied by x. Remember the rule that we utilize. That once we are multiplying in algebra and the variables are the same, we add the powers. The power here is 2, or the exponent here is 2. What is the exponent here? The exponent here is going to be, correct is right, the exponent here is 1. So therefore, this is going to give us 2 times 5 is 10. X squared by x is going to be, add the powers, it's x cubed. So therefore we end up with here 10x cubed, and it is 2x squared multiplied by 3y. We don't add the powers once the variables are different. So we get 2x squared by 3y is going to give us, or negative 3y is going to give us 2x squared by negative 3y is negative 6x squared y. Now what if we want to look at another example? Let's look at this example here. Here, another problem that may come on your exam paper is to remove the brackets and simplify x into y plus 4 minus 2x into 5 plus y. Again, what we are saying, via the distributive property, the x has to be distributed to everything that is inside of the brackets. Likewise, the negative 2x has to be distributed to everything that's inside of the brackets. So it's going to be x multiplied by y and x multiplied by 4. Likewise, when we are multiplying here on this side, it's going to be the negative 2x has to be multiplied by 5 and the negative 2x has to be multiplied by y. So that gives us here x multiplied by y is going to give me, that's right, xy, and x multiplied by 4 is going to give me what? X multiplied by 4 is 4x, 2x multiplied by 5 is 2 times 5 is 10, but remember it is negative 2x. So negative 2x multiplied by 5 is going to give me negative 10, and negative 2x multiplied by positive. Signs are different. Once signs are different and we are multiplying, the answer is going to be negative. Now look here. Here, in a previous video, we looked at the addition and subtraction of algebraic terms. We said that only like terms can be added and or subtracted. So when we look here, do we see like terms? I see a term here. Hold on. When we say like terms, what do we mean again? Like terms, that's right. Like terms are terms that would have the same variables, and these variables are raised to the same powers. So here, we see xy as a term. Is there any term that is like xy? Correct is right. Negative 2xy is a term that is similar or like xy, so we are going to group these together. Here as well, we have positive 4x and we have positive 10x, sorry, negative 10x. Again, these two are like terms. What do? Once we are adding and or subtracting terms in algebra, we firstly group the like terms. So grouping our like terms here, we have negative xy minus 2xy plus 4x minus 10. And once we have our like terms grouped together, we then utilize the laws of integers to add and or subtract the coefficients. Utilize the law of integers to add and or subtract the coefficients. Remember what we said from a previous video, that if there's no coefficient or no number, no constant in front of a number, of a term, if there's no number there and number still exists, that number is going to be 1. Correct is right. So this here is 1xy minus 2xy. What is 1xy minus 2xy? Here, we are going to utilize only the coefficients to work it out. So this is positive 1, negative 2. Utilizing our laws of integers, we subtract the smaller from the bigger and carry the sign of the bigger. It gives us negative xy. Again, it's negative 1xy. And what is 4x minus 10x? 4x minus 10x. Signs are different. It's positive 4, negative 10x. Positive 4 and negative 10x. Once the signs are different, and we are adding and or subtracting our terms in algebra, we subtract the smaller term from the bigger term and carry the sign of the bigger term, giving us negative 6xy. So our final answer here, remember, in algebra, we cannot add and or subtract terms that are not alike. So this term is totally different to this one. So those cannot be added and or subtracted. So our final answer here is negative xy, negative 6x. That's our final answer. What about this case? What if we had x squared multiplied by this entire bracket here, and this entire bracket here is 3x plus 5, or this one, negative 3x, that entire bracket is negative 3x multiplied by the entire bracket, it's 4x plus 2. So again, we are going to utilize the distributive property, which says that the x squared is distributed to everything that is inside of the brackets. So it's going to be the x squared multiplied by 3x and the x squared multiplied by 5. Also, for this one as well, it is going to be negative 3x multiplied by 4x and negative 3x multiplied by 2. So now we know what we have to multiply. Utilizing the distributive property, x squared multiplied by 3x. X squared multiplied by 3x, x squared multiplied by 3x is multiplied by coefficients. The coefficient here, in this instance, the coefficient in this instance is 1. So it's 1x squared multiplied by 3x. So I will multiply my coefficients. 1 times 3 is 3. And multiply my variables. Once the variables are the same, we are multiplying the variables, then we add the exponents. The exponent here is 2. The exponent here is 1. So it's going to be 2 plus 1, giving us, for this case, it is going to be 3x cubed, tell us. And now we do x squared multiplied by 5. It is only x squared multiplied by 5. So x squared multiplied by 5, standard form of writing our algebraic terms is to put the number first. So it's going to be plus 5x squared. And now we work this one. Here we know what to multiply. Just follow the blue arrow. So it's going to be 3x by 4x. Negative 3x, sorry. So it's negative 3x, negative 3x. Negative 3x multiplied by 4x. Negative 3x multiplied by 4x. Again, multiply out. Let's multiply out our coefficients. So it's negative 3 times 4, giving me negative 12. And multiplying our variables. Here it's x times x. The variables are the same, so we simply add the powers. The power here is 1, the power here is 1. So it's going to give us here, it is going to give us here, negative 3 times positive 4, it's going to be negative 12. And x times x is going to give us x squared. We then do, what is negative 3? Follow the yellow arrow now. Negative 3x multiplied by positive 2. Negative 3x multiplied by positive 2. Negative 3x multiplied by positive 2. We just add the coefficients. Sorry, not add the coefficients. We multiply the coefficients. So it's negative 3 by positive 2 is going to give me negative 6 and the x. As you can see, that when we are multiplying, utilizing the distributive property, whatever is outside of the brackets has to be multiplied by everything that's on the inside of the brackets. So after we have multiplied it out, we ended up here with 3x cubed plus 5x squared minus 12x. This seems a little jumbled here. So let's just erase this a bit. This seems a little jumbled. So what are we going to end up with here? My eraser seems to be giving me trouble. All right, let's just clear it up a bit. Clear it up a bit. Right. So what are we going to end up with here now? Here, what we are going to end up with is 3x cubed. Let me just run it over. 3x cubed plus 5x squared minus 12x squared minus 6x. Now remember, when we are doing addition and subtraction, so here is this. We are not doing maths in silos. We are not doing maths as concepts, as a body of concepts that are separate and apart from each other. Every concept in maths impacts every other concept that you would meet. We did addition and subtraction of algebra. So we are down to this line. This is not your final answer. It can be further simplified. The question says remove the brackets and simplify. It can be further simplified because there is some addition and subtraction taking place here. If I'm to simplify it via addition and subtraction, I must recall the rules for addition and subtraction. If you have forgotten those rules, you can go back to one of our previous videos and look at addition and subtraction of algebraic terms. But the basic rules are you add the coefficients. So this becomes here 3x cubed, and it's going to be minus 7x squared, like terms, minus 6x. And that is our final answer. So here, what we have looked at thus far is multiplying a binomial. Remember what we said a binomial was? A binomial is any algebraic term, any algebraic expression with two terms. And a monomial is any algebraic expression with only one term. So here, we multiplied a monomial by a binomial, and we did some simplification. Now let's go look at finding the product of two binomials. Remember what binomials are? So let's look at an example here. Remove the brackets and simplify. What are we removing the brackets and simplifying? We're removing the brackets and simplifying. 3x minus 4. This is one binomial here, and we want to multiply that binomial. We want to multiply this binomial by this binomial. How do we do it? There are two approaches that I would like to share with you. The first approach is to utilize the concept that we learned from before. Now here, everything inside of this bracket here has to be multiplied by everything that is in this bracket. So what we can do to achieve that is to take this first element here and multiply it by the entire second bracket. Let's just run that over again. So running that over again. Here what we say. My eraser is giving me trouble again. Right. So we want to find the product of the two binomials. To find the product of the two binomials, we have to multiply this binomial, eraser I'm using. We have to multiply this binomial by this binomial. To achieve that, we need to multiply everything inside of this brackets by everything inside of this brackets. How can we achieve that? What do you think? That's right. What we can do is that we can take this first element here in this bracket and multiply it by the entire second bracket. And likewise, we take this one, hold for me, this is not just 4, this is negative 4. So we take negative 4, all of this here, and multiply it by the second bracket as well. That gives us this. And if you recognize that this 3x is multiplied by everything in the second bracket, this negative 4 is multiplied by everything in the second bracket as well. Remember that concept we learned from before. Whatever is outside of the bracket, according to the distributive property, whatever is outside of the bracket has to be multiplied by everything that's on the inside of the bracket. Yes? So even with our product of two binomials, we could have looked at it like that. That whatever is outside of the bracket, we can take this as our bracket. And whatever is outside of our bracket here, which is this, has to be multiplied by all of our bracket. So we get this line. Now, what we are going to do, take the 3x, multiply by the 2x. That's what we saw from before. Take the 3x, multiply by the 5. Likewise, the 4 by the 2x and the 4 by the 5. Giving us what? It's going to give us 3x by 2x. What is 3x by 2x? 3x by 2x is going to be, correct is right, it's going to be 6x squared. And then 3x by 5 is going to be 15x. And then negative 4. Now remember that once there's numbers with signs, we must utilize at all points in time our laws of integers. What are our laws of integers? If the signs are the same, we replace with a positive sign once we are multiplying. If the signs are different, we replace with a negative sign. So this is negative 4 multiplied by 2x The 2x is positive. If a number does not have a sign in front of it, that number is still positive. Please check the previous video if you're still having some challenges with these. So it's going to be negative 8x, and negative 4 by positive 5 is negative. Oh, I was going to write positive. It is negative. Signs are different, so it's going to be negative. It is negative 20. Now check here for me. Look here for me. Let's see if that answer is correct. You can't see what I have there. Let's erase it and have a look. So what we had is 6x squared plus 15x minus 8x minus 20. Let's see if that's the answer. 6x squared, let's check. 6x squared, and it seems that that is the answer. It is 6x squared plus 15x minus 8x minus 20. But hold for me. Remember, the question asks that we remove the brackets. We have done that, but have we simplified? Let's check. Here, this is 6x squared. Is there any term like that in my expression? No, there's none. But here I have 15x, and negative 8x. Are not those two terms alike? Yes. So we need to simplify them. So this here now, simplifying them. Remember rules for addition and subtraction of algebraic terms. It now becomes 6x squared plus 7x minus 20. And we have successfully removed the brackets and simplified our algebraic by our products of two binomials. Now remember I said that there are two approaches that I wanted you to look at. One is this really nice approach, but there's another one that is a bit shorter, and I'm hoping that we can look at that as well. Here we see that when we multiplied these two binomials, we ended up with 6x squared plus 7x minus 20. Now there's another approach that we can look at to assist us in solving or finding the products of two binomials. Now, I can't, it's on my mind, it has been bothering me for a while, so I can't help but share it with you. I have this little issue. Now, if you know where I live, this is where I live. There's a little drain that runs between, and here is my neighbor. So, I'm a teacher, so you know we don't get much money. So this is my little house here, and my neighbor, you know, possibly an SS3 or somebody, a big shot, this is their big fancy house. Now I can only afford to plant a nice little mango tree. So here's my mango tree, it's growing really nicely. It's now mango season, and so my mango is in season and the mangoes are falling to the ground. Mangoes are falling to the ground. It appears that some of my mangoes from my mango tree fell into my neighbor's yard. Any good neighbor is going to take those mangoes and just toss them across slightly. My neighbor has been taking my mangoes and eating them. I have an issue. I went and I spoke to my neighbor, and it resulted in a little argument. So, we called for the police. The police is coming. Here's the police. Yes, the police is coming. When the police gets here, the police gets to the first part of my land. When the police gets here, so here is the first part of my land. When the police gets to here, the police gets to the last part of my land. Police is driving across. Woo! Woo! He gets to here. He gets to the first part of my neighbor's land. Let me put that in blue. I had to share it with you all. I'm hoping that you all can help me to resolve my situation. I had to share it. I'm frustrated. So, gets to my neighbor's property, gets to the first part of my neighbor's property, comes across here, gets to the last part of my neighbor's property. Yes? Police comes, gets out of his vehicle, and he looks at the property. He says, well, you know what? I recognize that. Here is the outer part of your property. Here is the outer part of your property. And here are the inner parts of my property. I'm a bit lost as to what the police is trying to tell me. But what I recognize is that this little interaction has helped me to understand a bit, and I'm hoping that it will help you to understand a bit, another approach to solving or finding the products of two binomials. It's called the FOIL rule. The first, outer, inner, and last. The first, when we look at outer and inner, we are looking at the two binomials together. The two binomials together, the outer portions of the two together, the inner portions of the two binomials. The first, when we speak to first, we are looking at each binomial by itself. My property has a first and a last post. My neighbor's property has a first and a last post. But when I consider the two properties together, they are outer and they are inner. So here, the FOIL rule. What is our FOIL rule? Our FOIL rule says this. Our FOIL rule says that when you are finding the products of two binomials, utilize the FOIL rule. Know who is first, know who is last. And then, to solve it, all you do is first by first, outer by outer, inner by inner, and last by last. So let's see how that manifests itself here now. Can we firstly identify who is first and who is last, who is outer and who is inner? Remember my little problem with my neighbor. For me, my property is a first post and a last post. My neighbor's property, there's a first post and a last post. But when we bring them both together, yes, we have the two outer parts to the properties, and we have the two inner parts to the properties. So look here for us now. Here, we have this. Can you see my property? This is my property here. You see my neighbor's property? My neighbor's property here. What is first? This is first. What is last? This is going to be last. For me, for my neighbor, this is going to be the first post, and this is going to be the last post. But when we speak to outer and inner, speaking to outer and inner, we bring the two properties together. Bringing the two of them together, this is going to be the outers, and these here are going to be the inners, inner. So we utilize our FOIL rule. It is first by first, outer by outer, inner by inner, and last by last. So it's going to be first by first. You see that? The first in my property by the first in my neighbor's property. And then outer by outer, the two outer pieces together. Then we do inner by inner and last by last. And all we do is just multiply them. So first by first here is going to be 3x by 2x. 3x by 2x gives me 6x squared. Outer by outer is 3x by, let's just go back a bit. So it's going to be 3x by 2x is 6x squared. And then we do 3x by 5 is going to be plus 15x. Then we do, so that is first by first, outer by outer. Then we do inner by inner. It is negative 4 by 2x. So it's going to be negative 8x. And then we do last by last. Last by last is negative 4 by positive 5. It's going to give me negative 20. Again, like across here, we have the same thing. 6x squared plus 15x minus 8x minus 20. We need to simplify inside here. So it's positive 15x minus 8x, which gives us 6x squared plus 7x minus 20. Is that our answer? Let's check and see. Whew. I've made it a bit too clustered for you. Let me just clean it up a bit. That's what we have. Yes, the same thing as across there. 6x squared minus 8x minus, 6x squared plus 15x minus 8x minus 20. And then we come down here to 6x squared plus 7x minus 20. Let's look at another example. Remove the brackets and simplify. Again, a case of products of two binomials, and we can utilize either of the two approaches. Again, the first approach is to take everything that's in the first bracket and multiply by the entire second bracket. So we'll take the 2x squared and multiply that by the second bracket, and then the negative 3y and multiply it by the second bracket. Again, remember, based on our distributive property, whatever is in front of the bracket has to be multiplied by everything that's inside the bracket. So it's going to be 2x squared by 5x, giving me 10x cubed. So it's going to be 2x. So it's going to be 2x squared by 5x, giving me 10x cubed. And 2x squared by negative 4y, giving me negative 8x squared y. And negative 3y by 5x. So let's see what it gives us there. So what is in front of the bracket has to be multiplied by everything that's on the inside of the brackets. So here it's going to be 2x squared. Let's follow the red arrow. It's 2x squared multiplied by 5x. It's going to give me 10x cubed. And then following the green arrow, it is 2x squared multiplied by negative 4y. Remember, if signs are different and we are multiplying, answer is negative, so it's negative 8x squared y If you need to recap how we multiply algebraic terms, please check the previous video. And let's look at the blue arrow, sorry, orange arrow. It's negative 3y multiplied by 5x is going to be negative 15xy, and negative 3y multiplied by negative 4y, following the blue arrow, it's going to be plus 12y squared. It asks us here to remove the brackets and simplify. So we need to check here now, addition and subtraction is taking place. We need to check to see if there are like terms. Are there any like terms here? This is a term in x cubed. Do we have any other term in x cubed? This is a term in x squared y. Do we have any other term in x squared y? No, thus far. This is a term in xy. Do we have any other term in xy? No. This is a term in y squared. No other term in y squared. So we don't have any like terms to add and or subtract. So basically that's our answer. It's 10x cubed minus 8x squared y minus 15xy plus 12y squared. Remember, this is one approach. The other approach is for us to utilize FOIL rule. And I'm hoping that my little example of me and my neighbor, it is not true by the way, but my little example of me and my neighbor will help you to understand the usage of the FOIL rule. So we are going to try this again utilizing FOIL rule. FOIL rule is first by first, FOIL for oil. For oil. FOIL rule for oil. It is first by first for the F, outer by outer for the O, inner by inner for the I, and last by last for the L. So here again, how do we know who is first and who is last, who is outer and who is inner? Use the bracket separately. Using the bracket separately, this here, the first one is going to be the first item in this bracket, so that is first. This one is going to be the last in this bracket, so that is last. In this bracket separately. So first and last, we separate the brackets individually. For outer and inner, we bring the two brackets together and look at who is outer and who is inner. So for this second bracket, this is first and this is last. Now bringing my two brackets together, here, bringing both of them together, we look now, who are the outer pieces? The outer pieces, this is going to be outer, this is going to be outer. So that is outer, outer, and two brackets together still. Who are the inner pieces? The inner pieces, this here is going to be inner, this is going to be inner, inner, and this is going to be inner. So then we utilize our FOIL rule. Multiply the first by the first in this bracket by first in that bracket. Multiply the outers, the outer one here, the outer one here. Multiply the inners, inner here, and the last there, last there. Let's look at our arrows and see what they tell us. So utilizing our arrows here, we say it's first by first. Did we have that correct? Yes, we did. First by first, it is going to be 2x squared by 5x. 2x squared multiplied by 5x is going to give us 10x cubed. And then we go. That is which one now? Yes, you're correct. That is outer by outer. So it's first by first. Then the outers, outer by outer. It is 2x squared multiplied by negative 4y. It is going to give me negative 8x squared y. And then we do what? It's for oil. So we did first by first, outer by outer. It is now inner by inner. Inner by inner is going to be negative 3y by 5x. It's going to give me negative 15xy. And then we do last by last. Last by last, let's follow that blue arrow. That's right. It is a negative multiplied by a negative. It is plus 12y squared. Now remember, we said that this method here is an alternative method to this one. Do we have the same answers? Yes, we do. And so our final answer is going to be 10x cubed minus 8x squared y minus 15xy plus 12y squared. So I want to leave you with this question to ponder on until we meet again. The product of a binomial by a trinomial. What do you think we need to do when we are multiplying a binomial by a trinomial? Try this question here for me. 3x minus 5 all multiplied by 2x squared minus 4x minus 1. Try that question. When we meet again, we shall look at the solution to that question. Let's just recap to ensure that we have covered all our bases. At the end of this lecture session, at the end of this video, we are now at the end. So you are now able to, I am hoping you are now able to explain the term binary operation. You are now able to solve mathematical problems using binary operations. And you should be able to describe the distributive property and solve problems as we did highlight earlier using the distributive property. Goodbye for now. See you in the next video.